properly. So let's just review real quick how to factor x squared minus 16 like we did last time by quick factoring. Once again, we can quick factor because our leading coefficient's 1. So you do it multiplies to be a times c and adds up to be b. My b value is 0 in this one. We're missing the middle term. So we know that's 4 times a negative 4. 4 plus negative 4. Check, check, right? Now because we can quick factor, we can throw in our parentheses as we know and learned last time. Put an x and x and then insert plus 4 minus 4. Now what I want you to notice is they're opposite signs, which makes the middle term cancel out, correct? One's positive 4x, one's negative 4x, making the middle term cancel out. Now what we just did was we actually just factored 2 perfect squares. So there actually is a trick we can use to factor 2 perfect squares instead of doing quick factoring. So watch. If I square root the front thing, it is just x here. That is a perfect square. Do you guys see what I mean by perfect square? It square roots perfectly. But you wouldn't square root the negative. You just square root the 16. Square root the 16, we get 4. We've already done this. We already know the answer. I'm just showing you another way to do it. So with this being the case, you would say, okay, is it subtract or plus? Well, it's subtract. If you are subtracting 2 perfect squares, it'll always factor to be conjugate pairs. Now, conjugate means a change of sign in the middle, opposite signs in the middle, because that makes the middle term cancel out. So I put an x in 4, x in 4, one would be plus, one would be minus. Okay, see how to do that? Now here's the kicker. You've got to be sure that it is subtracting 2 perfect squares. You actually cannot factor adding 2 perfect squares. See, look, the sum of 2 perfect squares doesn't factor. Watch me even try to quick factor it. Multiplies to be 16 and adds up to be 0. 4 times negative 4. Well, that's not negative 16. Do you guys see how that doesn't work? Therefore, that doesn't factor. Now look, even if I was to just square root the front thing and get x, square root the back thing and get 4, people will say then, can't I just do x and 4 plus plus? Well, think about it. If we have x times x, that's x squared, plus 4x plus 4x. That would be plus 8x. You guys see how that has a middle term if there's 2 pluses? Which this one doesn't. Plus 16. So it has to be subtracting 2 perfect squares, which makes sense. Think about it, guys. A positive times a negative always has to be a negative. And they have to be positive and negative for the middle term to cancel out. So if you're subtracting 2 perfect squares, you can do this trick. So let's practice it. Here we go. Can I factor this? It's 2 perfect squares. Square root the front thing, I get. Square root the back thing, I get 2. So this will factor to be x plus 2, x minus 2, right? Okay, great. Okay, what about this one right here? X squared plus 81. Can't factor because it's plus. You can't factor adding 2 perfect squares. How about this one? What would it factor to be? Good. X minus 7, x plus 7. Very good. Can I factor this? No. Adding 2 perfect squares cannot be factored. Okay, great. All right. So we've just seen. Actually, I'm going to go back one and show you an example where this is really useful. So let's say we had 2 perfect squares such as this. If I asked you to factor 81x squared minus 49, this would take long factoring, wouldn't it? If I did the long, good old school way. So learning this trick is so useful when we get really hard ones or long ones to factor. Square root the front thing, I get 9x. Square root the back thing, I get 7. So this will factor to be 9x and 7, 9x and 7 plus and minus. So do you guys see how that was so much quicker than having the long factor this? However, long factoring would work. Okay, so everybody, we just learned when we're factoring with 2 perfect squares with no middle term, if it's subtraction, it'll factor to be conjugate pairs. And if it's addition, we cannot factor the sum of 2 perfect squares. Now, these are actually 2 perfect squares with a middle term. Now, here is a trick we can use to factor 2 perfect squares with a middle term. So everybody, look at the end terms. They are perfect squares. We have to check something real quick. The square root of x squared is x, correct? The square root of 81 is 9. Now think about it. We have a middle term, so it's not going to be plus or minus, correct? Now think about it. If we were going to double distribute this, wouldn't there be 2x times 9s when we're double distributing? X times 9, and then you'd think back to, look, you'd be distributing, you said there'd be 2x plus 9s, or 2x minus 9s, if we were going to distribute this out, right? So you have to check, what's 9 times x? 9x. Well, there will be two of those, 9x and 9x. Does that truly add up to be the middle term? Yes. So you can use a trick for this, but it has to add up to be that middle term. Does that make sense? The front thing and back thing multiplied together, there will be two of those. Think about double distributing. So make sure you check that. So there are times when it doesn't work, where the middle term is those two things added up twice, and you can't do this trick. Okay, so since 9x and 9x does add up to be 18x, it will factor to be x and 9, x and 9. Now it can't be plus and minus because there is a middle term. Doesn't it need to add up to be negative 18? So what signs are they both? Minus 9. You guys see how it's just the same sign as the middle? 2x minus 9. See how we have two negative 9x's, everybody? Okay, awesome. So that was two perfect squares. So let's look here. We have two perfect squares on the end. That's x and square root of 81 is 9. Now check middle term. So it's okay that it's plus. Our middle term is 18x. 9 times x is 9x. If we have two 9x's, and we would if we were going to double distribute this, would it add up to be 18? So then we have x and 9, and what would the signs be? Plus. Okay, awesome. Now if I so desired in my heart, could I rewrite this if I really wanted as x minus 9 squared? Doesn't this and this mean the exact same thing? Is one better than the other? No. So do I care how you write it? No. We have questions? Yes.
So, this one is negative 18.
No, because it's a middle term, it doesn't need to cancel out, so these are just both need to be negative. Because if you think about double distributing, won't I have two negative 9x's, which would add up to be negative 18x. Does that make sense? Good question. All right, so let's check this here. See, I would have to long factor this if I hadn't taught you this trick. But what you're going to notice is the front and back term are perfect squares. But before we move on to our trick, we've got to check. Square root the front thing, you get 2x. Square root the back thing, we get 5. If we were distributing, we would have 2x times 5, which is 10x. That would happen twice. Does that truly add up to be the middle term? So this will factor to be. Middle term is there, so it's not going to be opposite signs. 2x and 5, 2x and 5, and it needs to be positive 20, so they must both be plus. Pretty easy, right? As long as you can think about all of those elements. Okay, so that same idea works on this example, notice. You'd say a perfect square, a perfect square. Square root, we get 2x. Square root, we get 5y. Check though. This times this is 10xy. So we should have two 10xy's adding up to be our middle term, and we do. So then this will factor to be 2x, 5y. 2x, 5y, and then it's positive 20, so plus, plus. Now, if we didn't know this trick, we'd have to long factor. We would get here. It would just take us so much longer. Okay, so let's practice. Can I factor this? What will it factor to be? 3x and 4. 3x and 4. Do we know what we're doing out there? Square root, square root. Then should it be what signs? Plus and minus, so our middle term will cancel out, correct? Okay, so what would this factor to be? Put your parentheses, square root the front thing, you get 3x, 3x, back thing, 4y, 4y, so then it should be a plus and minus. If I made this a plus sign, what would you say? Can't factor it. Okay, good. Great. Okay, awesome. So let's just make sure now we've seen all those elements that we're good to go. If you could just watch, I don't think you should be happy to take notes at this point. So this should factor to be, let's see, square root the front thing, square root the back thing. To me, we get 3x here and we get an 8y. 3x times 8y is 24xy. Do you agree? Now, wouldn't there be two of those? So does that add up to be the middle? Then we're good. 3x, 8y. 3x, 8y. What are my signs? Plus and plus. All good with that. Okay, let's go to this one. What's this going to factor to be? Minus 8y and 3x plus 8y. Okay, what about this one? What is it going to factor to be? 3x and 8y, 3x and 8y. And then what are my signs? Minus, minus, yeah? Because the middle term is negative. Okay, looking good out there. Okay, what does this factor to be? What? Oh, you can't do it. Okay, good. There will be one on the exam, guaranteed. it's a section that just says factor that can't be factored, and then people do it on accident. You guys see what I'm saying? You got to really remember what can work. Okay, so let's look at this one. Okay, what would the square root of the front thing be? 4n, square root of the back thing? 9n. It's two perfect squares with no middle term. Are we good to go since this one's subtraction? It would be plus n minus. Okay, you guys are doing awesome. Just stick with me. We're actually going to have a lot of in-class time for homework today, so stick with me here. Square root of the front thing. 2a, square root of the back thing. 3b squared. Okay, so can I actually factor this one? Okay, so what would the signs be? Plus and minus. Do either of these quadratics factor more? No, okay, good. You're right. They're not two perfect squares. Okay. Okay, now looking at this one, people will get confused. They'll go, okay, well, 32 is not, if I try to square root it, 32 is not a perfect square root. Okay, then you can't do that. But you shouldn't be doing that anyways yet. Remember, before you try any factoring technique, the first thing you check is there a greatest common factor? This is one I would write down in my notes if this was me. So once again, you got to check before you do any factoring technique, what's the greatest common factor if there is one? And there is a 2. So I pull out a 2, divide by 2, divide by 2. That leaves me with 16x to the 4th minus 1, everybody. Questions up to here. Now from here you should say, does anything factor more? Well, look inside. Isn't this and this a perfect square? So the square root of 16x to the 4th is actually 4x squared, isn't it? The square root of 1 is 1. And it is missing a middle term and it's subtraction. So we know it's going to factor to be 4x squared and 1, 4x squared and 1. And what are the signs? Plus and minus. Correct, everyone? Questions on this point, up to this point? Now from here, you got to check again, because look at your answers. This is good. We factored that completely. This is two perfect squares. Adding two perfect squares with no middle term. Can it be factored? No, so that's factored. That one's done. That one's done. But what about this one? Square root of the front thing we get. Square root of the back thing we get. And it's subtracting two perfect squares. So this keeps going. 2x and 1, 2x and 1. Middle term cancels out. That must mean this is plus and minus. So our final answer is 2. 4x squared plus 1, which didn't factor. 2x plus 1. 2x minus 1. You just got to make sure in every step, is it factored completely or can I keep going? How do you guys feel about this? Yes. Sure. No, because they're not the same sign. You're fine. But remember, not one is actually more simplified than the other, right? Even if they were both minus, they're equal, so you could write it. Okay, everybody focus now. New factoring technique. Okay, remember how I said on the test there'll be a section that just says factor and there'll be like 15 problems. You'll just have to know when you see a problem how to factor it. We've learned a bunch of different techniques. Remember I said if there is 4 terms, what method do we do? Grouping. So watch me do this one. Just a reminder. Pull out x squared, divide by x squared, divide by x squared. Left is x plus 1. Pull out a positive 4. Left is divide by 4, x plus 1, pull out x plus 1. Now guys, if this wasn't the same, wouldn't I have to stop and say it doesn't factor by grouping? Okay, so these divide out. Left is x squared plus 4. You better check your final answer. Does this factor more? Yes? Okay, what does it factor to be then? X plus 2. X plus 2 again? No, that would be a middle term. There's no middle term. So no, what does it factor to be? X squared plus 4 doesn't factor, right? Adding two perfect squares. Does everybody see? That would be your answer. Okay, now here is the thing. Let's look at this next problem here. This is where there is one little catch. There is 1, 2, 3, 4 terms. Do you agree? Okay, there is 4 terms. If I try grouping right now, let's see if it works. So just watching right now. If I group these two and group these two, I pull out the greatest common factor, which is x. Divide by x, divide by x. Left is x plus 10. Pull out the only thing in common here is 1. Left is 25 minus y squared. Well, that's not good. They're not the same. then it doesn't factor by grouping. Does everybody see? Then no, it doesn't factor by grouping. So instead, what you're going to notice is it's not in order, but with this one, we're actually not going to want to reorder it. Now, here's another thing to notice. Isn't this n term and n term a perfect square? If I square this, don't I get x? If I square this without the minus, sorry, I get a y. So x times y and x times y is xy. Is the middle term 2xy? No, so you guys see how we can't use our trick even. So we're stuck. There's 4 terms that we can't factor by grouping. So what we're going to do is a new method. I don't even know how to give it a name. It's just so I call it's alternate grouping. Alternate grouping. So I write that down in my notes. If it doesn't factor by grouping, if you have 4 terms and it doesn't factor by grouping, we use alternate grouping. I don't know what else to call it. So it's just kind of a process you'll have to memorize. So with this type, we're actually not going to want to reorder it in standard form because it's actually set up so that if we do this alternate grouping method, it'll work out quite nicely. So let me explain. We're actually not going to use this. I taught this differently and it went really good last hour. Okay, so what I mean by that is, if you'll notice, if I wanted, could I group the first 3 terms? Okay, but this is actually not supposed to be 25x. Erase your problem and put it right here was supposed to be 10x. Like that. This is the problem. Okay, so notice if I group the first 3 terms, it actually can be factored using one of our techniques we just learned. Isn't this and this a perfect square? Square root this, you get x. Square root this, you get 5. Now remember, there is a middle term, so they're not opposite signs. X times 5 is 5x. There's 2 5x's, which should be 10x. Is that our middle term? Yes. So what will this? Remember, we just did this. What does that actually factor to be? X plus 5 and x plus 5. Now, if I wanted, could I rewrite that as x plus 5 squared? And that's what I'm going to want to do for the context of this problem. If this is my final answer, it doesn't matter which one you write. However, for the context of this problem, that's what I want. Now look what I've done. I've just taken this piece and rewritten it in factored form, but aren't they equal? I've not changed the problem. I've rewritten it in a better format for our sake. Now I still have minus y squared. Does everybody see? Okay, so at this point now, if you're really good at factoring, what you'll notice is, do we not have 2 perfect squares now? Perfect square, don't we? So how do we factor 2 perfect squares? Square root the front, I get x plus 5. Square root the back, I get y. Now, the middle term is canceled out and it's minus. So this will factor to be x plus 5 and y, x plus 5 and y. And what would the signs be? Plus and minus. And there's our answer. Now, the parentheses aren't necessary at this point, so you could write x plus 5 plus y and x plus 5 minus y. All good? Or you could leave the parentheses. Does that kind of make sense? We're going to practice it again so that it's not, that's all brand new to you. You've never seen that before. Okay, let's do another one. So once again on the test, what you would do is try grouping, it doesn't work. Then you would say, okay, I'm going to use alternate grouping, which means I group the first 3 terms. Then I look at this and say that is actually 2 perfect squares here and here. The square root of p squared is p. The square root of 16 is 4. Now p times 4 is 4p. 4p and 4p, there's always 2 of them when we're double distributing. That does add up to be 8p. So we are good to move forward. We can use our trick. We know this will factor to be p and 4, and the sign must be minus minus. Instead of writing it as p minus 4 times p minus 4, we're going to write it as p minus 4 squared. And then we have minus q squared. Then you would then restart your thought process over. At this point, I now have 2 perfect squares. If I square root the front thing, I get p minus 4. If I square root the back thing, I get q. So let's put in some parentheses here. I'm going to have a p minus 4 and then a plus q. And it does, yeah, you're right. P plus 4. Sorry, I should have wrote p minus 4, huh? P minus 4 minus q. And we're done. Okay, a lot to remember, I know. So I have made a paper of all the factoring techniques we've learned, so that can be like study material for you, which keep in mind was nice of me because I didn't have to do that. So hopefully you guys will use that. I'll hand that out in just a second because we'll have learned so many factoring techniques. It'll be good to refer back to that. Does that make sense? Okay. Everybody, okay, just keep with me for a second. What should I do first? Okay, but if I try to square root it, what happens? We're in trouble. So what should I do? Pull out a 3. So then divide by 3, divide by 3. So the left is b to the 4th minus 16. Everybody stick with me. Is that 2 perfect squares? Square root the front thing and you get b squared. Square root the back thing, you get 4. This is 2 perfect squares with no middle term. So b squared and 4, b squared and 4. Plus and minus. Now I still have the 3. Does that factor more? Does this factor more? That factors to be b minus 2b plus 2. True? So there's your answer right there. Okay, awesome. Woo! Okay, this is all we just learned. I'm just summarizing it for everybody. Okay, so look. If you have 2 terms and it's quadratic with 2 perfect squares and it's factor to be conjugate pairs. If you have 2 perfect squares and it's addition, you can't do it. If you have 3 terms but 2 perfect squares on the end, as long as you square root it and it does add up twice to be the middle, you can go ahead and factor it, right? The sign stays the same. Okay? Awesome. Just making sure we're summarizing. Okay, last factoring technique to learn today. Factoring 2 perfect cubes. Writing this down. So here is the thing. Factoring 2 perfect cubes. A cubed plus b cubed will always factor to be that. Write it down, then I'm going to teach you a little trick. I used to remember it. A cubed minus b cubed will always factor to be this. Write them down so then I can start explaining how I remember these. Now here's what's tricky. You have to remember this. With 2 perfect squares, we can only factor it if it was subtraction. Addition did not factor. That is not the case with 2 perfect cubes. 2 perfect cubes always can be factored, whether it's plus or minus. Now a perfect cube means if we take the cube root, it'll come out perfectly. So I'll write it down, then I'm going to teach you how I personally just remember this. This is actually, once you've memorized this, this is one of the easier ones to factor, you'll see. So write it down, then I'll show you what I'm talking about. So a lot of teachers will just say, this factors to be this, memorize it. But I'm going to show you how I remember it because we have enough to memorize as it is for this upcoming exam. So this is how I remember how to factor 2 perfect cubes. It's a stupid trick, it is, but it helps me remember. So watch what I do, okay? So I cube root the front thing, and that is A. By definition, that's a perfect cube. I cube root the back thing, never including the sign, and I get B. Does everybody see? I'm going to throw parentheses around that. You guys see where this A and B comes from? Right there. Now what I do is just start this little chant I do, okay? So you do, at this point, you do, if this is in front, it's obviously the front. If this is in back, it's obviously the back. Okay, so here we go. You do the front times the front, then the front times the back, then the back times the back. So let me do that again. Front times the front times the back times the back. So watch us do that. The front times the front, A times A is, then the front times the back, then the back times the back. And then you guys see where that comes in? And now memorize how you fill in the signs. This is how you fill in the signs from there, okay? Everybody listening? The original sign drops straight down. So if it started with plus, it drops straight down with a plus. The next sign over is always going to be the opposite sign of that. No matter what that is, this will be opposite. So minus in this case. Does everybody see? And then the final and last sign is always, always, always plus. So that's a memorization thing. It is. But it's better than having to memorize that format, I think. So watch me rewrite this second one doing that same thing. If I cube root the front thing, I get A. If I cube root the back thing, I get B. A and B. Then I don't fill in the signs yet. Front times the front. Front times the back. Back times the back. Then the original sign drops straight down. The next sign is always opposite of that, so plus. The final sign is always, always plus. And that's always how it will factor to be. So let's actually put that into motion here. Here we go. It's a factor, x cubed minus 8. You say that is 2 perfect cubes. It's not 2 perfect squares. If I tried to square root it, it wouldn't work. Cube root the front thing, we get x, right? Cube root the back thing, never including the sign, we get 2. Now start your sum. You do the front times the front, x times x. X times x. Then the front times the back. Then the back times the back. The original sign always drops straight down, so this must be minus. The next sign is always opposite of that, so this would be, the final sign is always plus. And we're done. Here's a fun fact for you. The quadratic within 2 perfect cubes never, ever, ever will factor. So you can always know if it's 2 perfect cubes. At this point, you are done. Are we good? We're not going to get into why right now. Okay, let's practice again. Cube root the front thing, you get x. Cube root the back thing, we get 4. Front times the front. Front times the back, back times the back. Original sign drops straight down. The next sign is opposite of that. And the final sign is always plus. And we're done. So one of the easier ones to factor, really. Once you have the process memorized. Hey, watch. I think we get a picture with, but I want to do one that's a little bit harder. Okay, so this one. Keep watching. Cube root the front thing, we get 2x. True? Cube root the back thing, we get 1. Now you do the front times the front. 2x times 2x. Then the front times the back. Then the back times the back. The original sign drops straight down. The next sign's opposite. The final sign's plus. Always. Pretty easy. Okay, they just get a little bit more advanced as we go. Okay, so just continue watching for a second. So cube rooting the front thing, we get 2x, don't we? Cube rooting the back thing, we get a 5m squared. 6 divided by 3, right? 2. Now you do the front times the front. 2x times 2x. Then the front times the back would be 10. X m. Then the back times the back is 25m to the 4th. Now this sign drops straight down. The next sign's always opposite. The final sign's always plus. And I want to point something out. Like I said, do we have right here a perfect square and a perfect square? 2x and 5m squared. But before, it does have a middle term, doesn't it? Remember, before you can use your trick, don't you need to check? What's this times this? 10xm, and there's going to be 2 of those. Does that add up to be the middle? 20. Shouldn't it be 20 in the middle if it was going to factor? You guys see? So that trick does not work. Now, like I stressed, the quadratic within the cubic will never factor. But I just wanted to point out there really are some that have perfect squares on the end that don't end up factoring. Does that make sense? Our trick. Okay, great. I think we get the picture of that one. I do want to go through this one. Is it 2 perfect cubes? So cube root the front thing, and I get x minus 4. Cube root the back thing, I get 2x. So I'm going to throw in some big parentheses here. And I put in x minus 4 and 2x. Now I'm going to put in my, now I've got to do my front times my front. So very carefully. The front times the front would be x minus 4 times x minus 4, wouldn't it? Then the front times the back would be, not filling in the signs, 2x times x minus 4. Then the back times the back, 4x squared. Let's fill in our signs. The original sign comes straight down. The next sign is the opposite, the final sign's plus. Now you gotta combine like terms. So look inside here. I would get 3x minus 4, wouldn't I? Then right here we would have to distribute. X squared minus 4x plus 16. And then I would have right here minus 2x squared plus 8x. Then I have plus 4x squared. So let's combine like terms and then we'll be done. X squared minus 2x squared plus 4x squared is 3x squared. Negative 4x minus 4x plus 8x. Isn't that 0? And then plus 16. And now we are done. Okay, thanks. Questions on that? Okay, sweet. How do you guys feel about this stuff? Pretty good? I think you'd get how to do this, right? Same thing we just did? Be careful with your algebra? Yes? Okay, so everybody, no more examples, but I'm just making sure we understand. Watch very carefully. Two perfect squares subtract if factors to be conjugate pairs. Two perfect squares with addition can't be factored. If it has a middle term and it's two perfect squares and the square root of those twice add up to be the middle, it factors to be that same thing twice with the same sign as the middle term. If we have two perfect cubes with addition, we can factor it. Do the front times the front, front times the back, back times the back. Two perfect cubes with subtraction can also be factored. Correct, everybody? So just that was an overview of everything because it was a lot to remember. Okay, awesome. So 5.6, the rest of the time is yours. Take it serious because this is a lot of stuff to remember.